Hello, friend. Thanks for stopping by my channel. So, today we'll be going through a few of the estimation problems in system design. We'll set a timer to 45 minutes and then we'll have a break time of 15 minutes, so a total of 60 minutes. And this will be a buffer time. We will try to take few of the system design problems and only address the estimation part of it. The objective of this video is to from looking at a very abstract problem, trying to break it down into some actionable numbers that we can take to sort of guide the eventual design that will follow after that. For example, to take a concrete example, like if I have a system in mind and to take the system and then from that figure out if that system will have a lot of reads versus lot of writes, and based on that the services need to be scaled out accordingly and provisioned accordingly. So that's the key thing that we have in mind for system design. So to start with, let me just write down the first problem that I have in mind. So the first problem that I have in mind is given a system, given a hotel booking system, design a service that will tell top hotels viewed slash search queries done per user. So just to understand briefly what this actually means, we'll go down a little bit and basically if we have like a system like for example Airbnb, which has a number of hotels or stays that are listed there, and then the users are also firing some search queries. What eventually will happen is like when a new user comes up or the same user comes up in a different place, we want to figure out like for this given user what are the top hotels that he had seen, or what are the top search queries that he had queried in the past, so that we can better serve a good homepage for that particular user. So this particular problem is tied to two scenarios. One is the loading of the homepage, because whenever you are signed in to um, the hotel booking system, the homepage will load for you. Doesn't matter if it's on the app or a mobile or a client, I mean an actual website. So potentially like you can have a website and as well as a phone. So you can have your web interface or you can have your mobile interface, and all these places we have the person who is querying that actually that as a user. So let me call that as a user here. Let me actually take these guys to left. So the user will fire different kinds of queries via the web or via the mobile client, and each time it'll render some page there, and our expectation is we should be able to see the recent searches that the user had done. So what it needs to do is basically keep track of all the past queries, and that should go to a backend storage somewhere. And then when the next time the user logs in, we should be able to retrieve that what are the most recent versions that are recent search queries or hotels that are searched there. So as I mentioned, since there are two ways that there are two parts of the system. So if I assume the entire system to be sort of as a black box service which returns, and let's name our system as um, what should I name this system? User preference service, something like that. So uh, so this basically the user preference service. What it does is like every time we log in with the user here, these interfaces will basically go to this user preference service, and in here we'll just give out, this is the user ID, and what this will do is it'll tell you the list of last few or top search queries, comma, um, hotels viewed for users. And so that's, I think, one part of it, like when we are loading it. And then the other part of is like when the user is actually interacting with this web and mobile application, will be also storing the data in the backend. So let's say we have this mobile application, right? So just move this to here. uh, let's say we have this also the web application, let's name it the web application, and the interaction is actually different. So this interaction is just named as load home page. That's what we are doing here. And here actually we are firing some queries. uh, Actually do a query, right? So that's, I think, yes, yeah, so that's, I think, one thing that we can do. We can do a query, or also we can do a click. So these are the events that we need to keep track of, like what are these kinds of events that are happening, and these events should be logged somewhere. So whenever these interactions are happening on the client side, and this client side will be sending that to the server side application. So I'm going into bit detail into this high level architecture just to get a feel of it. What are the main components of it? Then we'll come to the estimation part. So this component, which is the let's call it the app server. So app server will have all these request incoming to it. uh, so basically it will have all these requests incoming to it, and there will have those events. So this will be sort of treated as log events. All right, and what log events will do is just log this information to the app server. And now let's actually come to our capacity estimation part. So let's select this everything here, move everything a little bit to the left. Right. So, and also I think we can reduce the size overall a bit, and maybe let's see how much zoom we have. Let's fix that to 100%. Yeah. So now if we select everything and increase a bit, yeah, looks fine. So at this point of time, we can start the capacity estimation, because we know there are at least two places where the services are interacting. Actually, let me complete the last part, which is app server will just pass this information to the user preference service. So the user preference service, there are actually two key parts. This section here. So let me just do it with the, say, with the red color. So the entire section here, and the other part is with the this different color, the entire section here. So this section on here is basically called the read part, um, and the section in here is actually called the write part. So these two interactions define what is our read and write design considerations that we should have. Now let's come back to our base estimations. So we have about um, let's say 100 million users. So we have around 100 million users in the system, and there are 100K hotels. And the queries can be anything, right? Like the users can fire a lot of queries. But in general, if we come down to some simplified estimation where we don't have to gauge how many queries that can come up, it'll be in that, like it can be thought of like a typical page will be loaded like 10,000 times per second. So that will be our read request. So these are our, should I say, like read volume, or let's actually call it read request itself. and then our write request would be about 1,000 events per second. And by event, I actually mean that um, by event, I actually mean these clicks and query events. So basically, if there are two cases that can happen, either we are given these numbers in beforehand, or we have to come up with these numbers somehow. So if we have 100 million users, and then we can distribute like where are the users are located across the geographies, and then at peak time what will be uh, the maximum time that all the users logs in, and then there are a lot of requests will be coming in. So we have 100 million users in the system, but I think the key aspect of the read request that we are concerned about is the peak load, like at a time how many users can fire the requests. So if we assume like about say out of those 100 million users, about 60% of them are active users. Again, I think this is coming like if we don't have these numbers in hand, and if we have to come up to those numbers, how we can come up to those numbers. So if we have like about 60% daily active users, and these parameters can change, we can say 70%, and then the following numbers will change. So if we have 60% daily active users, then we can have like 60 million users who are active across geographies, but then at a given period of time, um, this number will be possibly spread out within an hour. For example, if we say there are 16 million users who are active, but they are spread across different countries, and maybe within one country, maybe in US or within India and China, we have a sort of equal amount of spread. Like we have um, 30 million users in US, 10 million in Europe, and 20 million in India and China. So basically, those requests will sort of align their timing based on that, and they will all come in the peak hours. So we can think of about, say, one third of it, or 20 million users who will actually be active within a time zone. 20 million TAU within a single time zone. And so what that basically means is if we have those many active users within a time zone, they'll mostly coincide within some period of time. And what we can imagine is like out of them, maybe a 60% of those users will be active within a given period of time. So now I think we'll just jump up to one single consideration. So 60% of 20 million users are active within a span of, say, 6 hours of evening. So that's like the peak booking time or viewing browsing time for this hotel listings that we have. And that's also not like every day, but it's also peak hours, and that's mostly for example like weekends, so which is the peak load that we have to be concerned about. Now if we do a quick back of envelope calculations for this, so we have like zero point 0.6 of 20 million, which is like 12 million in 6 hours. So we have like 2 million user per hour, which roughly translates to, we have this, and then 24. If you translate that to per second, so 24 hour, 60, 60. So how much is that actually? Let me calculate it. It gives me, yeah, this is the number, and then we have 2 million, right? So we'll just do 2 million divided by 86400, not here. So we have about like 23 users per second. So even then, this read request, so this is like 23 users per second. But I guess the volume that we are estimating, this is quite large here. So we are estimating a lot of scenarios, and this has a lot of headroom to grow within that. And if we change some of the estimations here, like instead of 80%, if we assume like all of these are like 80% scenarios, and if we crunch it, like maybe the R will be within maybe 3 hours period of time, within that weekend when this is happening. So then we'll come up with these numbers a little bit differently. We'll come up with 80 million, and then if we spread them out, so 40 million, 50% is active within a single time zone, then 80% of that would be 32 million users who are active within a span of 3 hours. So then your this estimation will also change. That will be roughly like uh, 10 million per hour. So 10 million per hour will translate to almost 5 times of this current value that we have, which roughly say we have 150. So even then, this does not increase much. Like even if we crunch this to 1 hour, what basically happen is like this will all become one, and this will become 30 directly. So it'll increase 3 more times. So we come about like 450 users per second, or 450 simultaneous requests per second at any point of time during the peak load. But obviously it can crunch even more within the period of time. So we have sufficient time if we have almost like 20 times capacity of that, and it's easier for us to handle. So that's our basically the read volume, and the write request will be how many time they are doing the searches. So mostly they'll load the pages, and then they will actually click on something or search it. So that will depend on, I think that's the ratio that we can think of. Like if a user logs in and loads a page, then what's the chance that he or she basically clicks on that? So 1 in 10, I think it's a reasonable estimation. So if we have like around 450 users, or 450 500 requests per second as like initial estimation, so about 50 requests per second will be the right throughput for that. So yeah, I think that's the initial estimation that I have in mind for this system. And yeah, I think that's sort of what I have in mind. Let's actually move this a bit and then go down and start estimating on the new problem. So the next problem of estimation that I have in mind is what happens in the case of Twitter, right? So in case of Twitter, how to estimate the scale of Twitter? By the scale of Twitter, I mean it has multiple different services, but in a simplistic form, if we are building Twitter for the first time, uh, the expectation will be, let us write down the expectation of the requirements first, so it will help us to narrow down what are the things to consider. So if you are building a new site like Twitter, the first thing that we will allow is user should be able to create 140 characters tweet. User should be able to follow other users, and then the user has a feed of most recent tweets posted by other users. Most recent, and this also can be like most recent. We have this chronological timeline on Twitter, so that's I think one aspect of it. Or we can say if we want to have some sophisticated algorithm for feed ranking, like for Facebook, most relevant, and this relevant aspect is actually tricky to have. So this can be okay. Let's change this entire color. I don't want that. And most recent, most relevant tweets which are posted by the user. So that's I think one aspect of it. And okay, fine. Yeah. The other part that I have in mind is yeah, I think this is fine. The other part is users should be able to favorite or like tweets. So there's like a lot of data that we have to generate. If we think of a very high level, how the system should look like, let's actually fix on these requirements. Any other requirement that we have in mind is we are skipping the photo and video content for now for simplicity. We can add it later. So, and let's see if we have a better library for representing this user system. Scalidraw actually has some library system. So let's actually say software. Not much users architecture. Um, Information architecture. Yeah, I think this is fine. This we can add. That's fine. But I think what I need is like a user kind of stories. Architecture floor plan is not required. Or let's see, for all these cases, decision flow control, software architecture. Yeah, this should have some awesome icons. Yeah, nice. So what I need is like, yeah, exactly, perfect. So I need a group of users, and then I can have one user. So these are like two simple aspects. So basically, uh, I, I I can think of Twitter in terms of like individual users and then the group of users as well. So this group of users can be your, for example, your followers, and then this one user can be individually you. And then let's think of the interactions in terms of the user. I mean, do we need even the group of users, not or not? That's I think the question. So let's come to the how the interaction will be at first. So what we will have is, let's see if we have something like a website kind of structure. Chart, search, delete, home, time, bookmark, calendar, payment, balance, menu. I think there is some library for the website handling. Um, Not this one. Software logos. Yeah, actually, these two are fine. Perfect. And I can add the software logos. Yeah, and where I can have something like this here, which is quite big, but I can shorten it down. So this will be my website where the users, what they will do is they'll have some kind of interactions. So each of the users will have some different interactions. Let me point each of these to their corresponding places. So what the user will do is the kind of event that they can have is one is a tweet and the other is follow, and then the other option that we have is what should I say, uh, okay, like, and then the last one would be cool. Okay, so the last one would be to view the feed. View feed. So these are the four operations that we have on Twitter that initially what we are thinking. So there will be multiple events which are coming in, which is like some user created a tweet, some user followed some other user, some user liked it. So those are the events that we need to generate, and from all those events, so those are like input events. So we can think of like, let's actually select all these three scenarios and give them a color of, say, this purple. So these purple ones are all our incoming events that we want to generate inside Twitter. And then we have the view feed option, which has sort of this green color. And the view feed option basically tells this is the read operation. So whatever we have combined will create the feed, and then there will be view feed option. So the thing that we need to be able to handle is if we have a single system. So all of these will what it will generate is like a stream of events. So let's actually imagine if we have, say, internal to Twitter, some let's call it the master algorithm or something like that, which basically combines all of these events and generates the feed. Because ultimately, the what the user interacts is they'll create some events and then see a feed, and based on the feed, they'll start interacting with it again. So that's, I think, the relationship that we have. And what we'll do is it'll just interact with the master algo. The master algo will and this what the master algo will have as inputs. The master algo will have as input as uh, stream of events, and this stream of events, like how often this, so that will be my key read requests part of it. So that will be the key estimation aspect of it. And then let's come back to the other part. So what this master algo will do is like generate a feed. So at a very high level, like let's talk it, uh, call it a feed generation. What this master algo will have from here, it'll generate a some feed for a user, and this will be per user, feed generation per user. And what that basically will do is it'll allow the other user to sort of view that feed, and it'll come again to the same place, to the same interface. So the way we are interacting with this web interface, but eventually this is like a stream of, like, you can think of like they are all different APIs, and the kind of ways they're interacting is like either generating an event or reading the feed. So let's call it, this is the view feed part, and this is also fetch feed. So the way we should always have some feed prepared, and this should be something internal to the Twitter algo, which will prepare feed. And let's call this prepare feed. And what this prepare feed will do is based on some of the algo, and these two things should be done synchronously. Like the uh, I call it like event processing. I think that's a better name. Event processing system. So event processing system will process the events, will prepare the feed, will push the feed per user, and then the API at the end will again fetch the feed, and that's how basically the system keep on working. So now coming back to, I think, our key aspect, which is the estimation part of it. So let me bring all these things a little bit closer here. Um, yeah, something like that. And let's bring everything a little bit top. So now what we are trying to do is finding out how we can do a clean estimation of it. So let's call that part. Let's do the estimation in two parts. So the other one part is like event generation. How much event are we going to generate? So for that, few information that we need is how many users are there on Twitter. So let's assume Twitter have about 500 million users. Um, who are currently member of that, and out of that and let's call it 500 million daily active users. um, and those users, and now we want to see how much events they will basically generate. And obviously we can scale out and differentiate the event generation part, like how much tweets will be there, how much follow will be there, how much like will be there, into separate parts and treat all those events separately. And basically this event processing will have three parts, like it'll fan out all those events into three parts, and each service will handle that separately. So that I think we can add that architecture later. But initially what we will think of as like a single event processing part, um, we will consider them as different activities, but we will add them all together into a single event processing system. And then the other part is the feed generation, how many times you basically open a page. So the number of times basically user opens the page, that's always high, so that will be our read request. So if you have 500 million daily active users, if the users are split up into different geos in 50 30 20 ratio, so we have around like 250 million daily active users in same time zone. And if we have all of users in the same time zone, and then they should overlap into some key activity period of time, and let's call that key activity period around like 75% of users who are active at that period of time. So 75% are active in a period of say, I would say, of 1 hour. So if we have 75% of those users active within 1 hour, let's do a quick calculation on top of that. So if we have, let's say, 0.75 multiplied by 250, so we have 187 million. So roughly, let's say, yeah, or let's for simplicity call it 80%. So 200 million per 1 hour. So all the time these users are active, they are basically refreshing their feeds, and their feeds are refreshed, or the read requests are coming simultaneously. I think they'll be coming at some interval, but I think for our simplicity we are thinking like they are like logged in and we have to serve all those requests simultaneously. So if we have like 200 million users requesting for their feeds within that 1 hour period, and it's not sort of evenly spread out within that, then we have, let's come to our base estimation now. Let's call it, so we have 200 million users, then divide them by 24, divide them by uh, 200, right, million divided by 24 divided by 60 and divided by 60 again. So we come up with 231. So that's not a big number. Uh, 231 users or 231 requests per second. Let's call it 250 requests per second. We should be able to handle even higher than that. So let's have an upper cap of about 10,000 reads. So if we have like 10,000 reads, we have a lot of like almost 40x times. We can have 40x times load of this. So if we have 10,000 read requests per second, so that is the way I should have. And then once they generate that, how many times they will tweet it. So out of all those 200 million users or 250 users per second who are active, so out of those 250 users, only let's say 20% of them will tweet. So we'll have inside the event generation part, if 20% tweets, which means we'll have 50 tweets per second. And then how many of them will like other. So that will be a little bit high chance of liking other tweets. So we can think of it'll be almost 4 to 5 times of that, but not within a second. So uh, if you have that, it'll be sort of spread out within that. And out of those users who are logged in simultaneously, 50% of them likes, because that's a more likely event. So we have like about 125 likes per second. And then we have follows, which is also similar to tweets, and it can be thought of like 25% follows, or it can be even lesser, but I'm thinking just 25% for now. Then I come up with the number of about one fourth of it. So let's say 60 follows per second. So as we can see in terms of here, the likes is the key part, which takes a longer amount of time. It creates a larger volume, but in total they create sort of like the same number of requests. So if we only have like 25% time they tweet, uh, we'll eventually have almost the same amount of 25 reads or writes per second. But actually the thing is like this will not scale in terms of that. So even if it peaks, it'll peak like maybe 10 time of it, or 5 times or 4 times of this. So it won't be that high even if I think of like say 10 times of it. So it's like 20,500 writes per second. So that should be my expected throughput of write that I will see in the backend at any point of time. And that's like really, I mean, should I say, it's a very um, optimistic scenario in that case. How can I move this entire thing to the left? Um, can't I move to the left? I can move only up and down. Fine. Okay. So let's move this one here. So now we have some estimation, and let's bring these guys here. So this is actually a shorter option. So then we have like uh, 10,000 requests per second and 22,500 writes per second. This is obviously a read heavy system. So let me call this out as a separately, right? And finally, these are the two numbers that matters most to me uh, in this other color that we have. So it's a write heavy system, and we can think of like maybe 2000 writes per second. So 5 times or 5x time more read we have. So the read should definitely not be blocked on the writes, and the system should be designed on such that we should keep on serving the reads, and the preparation of the feed should happen asynchronously. And Yeah, that I think the key constraint that we put on the design system that we have created here. So at this point I think it's a good time to sort of check on let's see, um, how much. And another part is I think this is a throughput estimation, but one other thing that we can start estimating is maybe the volume or the storage. So if this is sort of sorted out, or like if you're given this, the other part of the estimation that you have to come up with is the storage estimation and the bandwidth estimation. So this throughput part will be given to you, like, or you can come up to it as, like, for example, in Airbnb case this was given, but for Twitter case it was not given. um, if we come towards the preparations for the storage estimation, let's see how what will be the storage estimation for there. So we have to store let's say um, not think about the derived data part, just the actual events that we need to store here. um, and also preparation of feed, let's not think about that. Only assume whatever the writes that are coming in, we have to just store them. So for that, we need to create, for example, a separate section here. Let's call it storage estimation. So in storage estimation, we have 2000 writes that are coming in, right? Like, and in that, in between here, we have, let's call it, um, everything will scale up approximately in that way. So we have 400 tweets coming in. So each tweet, as we know, is 120, 140 characters. So these are like all data coming in 1 second, and then we'll basically scale up. And if we have to store a data of up to 3 to 5 years, we can say how much data we need to store. So we have 400 tweets coming in. So each tweet will be of 140 characters, since we are only assuming um, integers, only assuming, what should I say, textual tweets at this moment. So we have like how much? 414, 56 and 5600 bytes. These are all bytes. And then there is that the other two events, follow and like. Those are basically not user generated contents, those are user generated events. But what we have to basically translate to some form of event within our system. So they will, for example, it will be a mapping. So like will be a mapping between a user ID and a tweet ID, and then there will be some timestamp associated with it. And if I think of as the minimalistic data, that's what we can need to store. And similarly, follow will be some user ID, and then some follow ID, the user ID that you are following and what point of time you are following that, doing that. And based on that, we can create multiple derived events out of that. So all this user ID and like ID, if we have this estimation, like the user ID is like a 64-bit or 8-byte character, the tweet ID is a 8-byte character, or because there are a lot of tweets coming in, let's actually take all of them as 16 bytes, or a really large one. Let's actually take it 8 byte. I think that's sufficient to have a lot of data. And then we have timestamp, which can be a larger one, but still we can think of as like a long data. So 64 bits I think is fine for that. So 24 bytes we can have for this, and the same thing will be there for follow. And each of them are coming at a rate of like we have 50 tweets here, let's call it actually 50 here as well for simplicity. So we have around 8 times of that, that is 400. Plus let's also calculate the number of likes that we will generate. So the number of likes will be 125 into 8, which is around 1000, and which is exactly 1000. And then on top of that we have 24 bytes. So my this estimation becomes like 1400 into 24 bytes. So this is the this many bytes we have to need to save per second. uh, and let's actually combine them together so we can have a rough estimation of the whole data set. That's 5600. We'll round it up, so we have 39,000, so we'll round it up to 40,000 bytes per second. If we have 40,000 bytes per second, we can now just do a upwards calculation. So we have 40,000 bytes per second, then we do um, 86,400 seconds. So that's within a day, and then it becomes this many within a year. So within a year, we already have 1.2. Uh, this becomes like 1.2 terabytes of data. within a year. So that will have be like 1.2 TB of raw data, and then so this will be 1. TB data per year, and it will increase if we have more data sets. So if we save it for say like 5 years worth of data, so it will be at least 6 TB, but there will be additional data sets and derived data which will be on top of that. And similarly, the throughput estimation for that is if we are sending this many data set, like we are sending um, actually 40,000 bytes or 400 megabytes of data per second, and we are reading how much data we are reading. So what will be the size of, so the bandwidth will not be limited by the write size because write is actually less, but read is actually quite higher. So if I assume like there are 10,000 requests per second, and my so now let's come to the bandwidth estimation. So that will depend on the size of a tweet, size of a feed. So size of a feed will have every time will generate some, let's say 20 tweets uh, per feed. So that means in each request. So in each request, if we serve 20 feeds, which means we have 20 tweets, which means we have around 3,000 bytes per feed. And then how many such feeds we are actually fetching? It's actually 10,000. So 10,000 requests that we are making. So 3,000 multiplied by 10,000 such requests. So that many bytes per second we are actually getting, which will be how many zeros will be there after that? 7 zeros. So which is not high actually. It's 30 MB per second. And this is actually quite low because we are limiting the only it to a textual social network, but that will be very not very interesting. So in that particular case, uh, the bandwidths will be limited. But if we add images and video, then we have to add that estimation, add that factor into estimation, like what's how many times a user will post an image and how many times the user will post a video, and that will add additional challenges to the bandwidth estimation there. So yeah, I think that's all that I have in mind for capacity estimation today for these two systems. Thank you for joining in. Let's meet in the next session. Thank you.